Finally, we are in a position wherein we'll be able to place the dielectric between the plates and see what exactly happens. So here we are trying to understand the math and the theoretical aspect of what happens and how it affects other things. Okay. So how dielectric helps in increasing the storing capacity of a capacitor. How does it do that and the math behind it. So we can understand this in two ways. Version 1 is with the help of Coulomb's force. Version 2 is with the help of electrical field lines. Now, see, it's simple. We have a plate, There are certain positive charges and similarly there are same number of negative charges. What if I happen to place, say, one more negative charge over here? What happens? It will attract a positive charge. What if we place a positive charge over here? It will attract a negative charge. What if we are able to do this with a lot of them? What I mean is something like this. What if this happens, right? A lot more closer, but it is going to help us understand. See, this material is a dielectric material, and these are the polarized molecules. Since it's exposed to an electrical field, right, pre-existing electrical field, they'll get polarized. So at this end, obviously the electrical field line is from left to right, is it not? So obviously the right end will have the positive charge and the left end will have the negative charge. So overall the net effect is that this end will have negative, let me do this, negative charges at the surface, right, on the surface, while this will be positive charge at the right end. Okay guys, so okay, this happens, so what? Well, when we have such bunch of negative charges and bunch of positive charges, what will happen over here? Without us doing anything, the number of charges will increase. Without physically changing the size of the plates, now it's able to hold more charges. Does it make sense? The Coulomb force between the closest end of the molecules and the charge on the plate. So basically, we're talking about this stuff over here, this end and this end. So we're talking about this end and this end. Molecules and the charge on the plate is attractive and very strong since they are very close by. Makes sense. This attracts more charges onto the plate than if the space were empty. That also makes sense. And the opposite charges were a distance d away. So we can see that the distance here has reduced. What I mean is distance of the positive and the negative, like over here at the bottom, it's same as the top. But with the dielectric, the distance between the positive and the negative is reduced. So that also plays a role, right? Distance plays a role. The formula tells it so, and we have seen that. Version 2. This will do with the help of electrical field lines. So again, in the absence of, in the absence of your dielectric, so this was, say, the scenario. Now, because of dielectric, what happens is this positive is able to, the electrical field line is able to stop at this end. This positive electrical field line is able to stop at this end, while this negative's electrical field line is able to stop at this end, and so on and so forth. Right, guys? So that would be the cases. Just a second. Okay, I'll just take a second to draw the arrow. right? So this will be positive, positive. Again, this is a very simplified version of what exactly happens, the scale that is. So this is what will happen, right? Does it make sense? So either ways, the result is the same, the explanation, right guys? Now, the write-up. So one of the things that will happen is polarization. The molecule within the dielectric material becomes polarized. When you keep a dielectric material in between an existing electrical field, they get polarized. This means that the positive and negative charges within the molecule shift slightly in the opposite direction. Okay. The positive charge moves in the direction of the electrical field while the negative in the opposite direction. What else happens? Internal electrical field. This polarization creates an internal electrical field within the dielectric that opposes the external field. So here, instead of this big fat set of lines, I can just do this. So because we have, see, remember, let me go this way. Let me change the flow. Here we'll have positive charge. Here we'll have negative charge. That's what I meant by end of it. Both explains the same thing. Now within the material, we have the positive to negative, right? Polarized electrical field. Outside, we initially had an electrical field of say E. Now it will become E dash. Overall, what happens is the net effect will reduce and end of it it'll be able to become E again. So there's a lot of a bit more complexity to this. So let me not go to that. But for now, you guys understand that because there is positive charges accumulated over here, negative charges accumulated over here, the net effect is that again net. Here you can see that everywhere there are positive and negative charges, but this space, right, the net is 0. But at the end, we have the positive and the negatives. So because of this, there is a electrical field from one end to other end. We can imagine that. Obviously, it won't be so. The net effect is that. Okay. So that's the point we are trying to make over here. So yes, as a result, the overall electrical field inside the dielectric reduces compared to that of the external field. Okay, yes. Then increase capacitance. This is the result. So what happens, and this is the result. When a dielectric is placed between the place of a capacitor, it increases the capacitor's ability to store charges. We saw why. This is because of the dielectric reduces the effective electrical field, allowing more charges to be stored for the same applied voltage. Right? Because traditionally the electrical field lines were in this manner. Because we have, so this is say initial. Because we have EP, what happens? The net will be EI minus EP. So difference in the electrical field is what will increase. I might not be making sense now, but you will understand in time. So this is the extra bit of electrical field that the overall charges can establish. Overall, the potential will be the same, but this extra bit of charges will be able to accumulate for the same potential difference between the battery. I'm sure it's not exactly clear. It's okay. Again, this topic, you need to go to the end to understand the entire bit. So you have to be patient to learn this. Okay. So it'll just take a few more videos. I know it's a lot of videos actually till now. A few more videos. This becomes the dielectric. This is because the dielectric reduces the effective electrical field, allowing more charges to be stored for the same applied voltage. This is pretty important, and yes, it's confusing. We'll come back to this again. Overall energy stored, obviously it will increase. Dielectric can store electrical energy through polarization. This stored energy can be released when the external electrical field is reduced. This is the job of a capacitor. So this is about the job. This is about the technicality of things. This is before kind of effect, not exactly before, but with the material, right? This is with the material. dielectric material. This is to do with material. This again is to do with the effect. And this is the result. And that's the job. Not job, my bad. Job. Okay, guys. Yeah. This is what we need to understand a lot more. We'll come back to that again. For now, you guys, this is only for your understanding. Okay. But yeah, do copy the diagrams at least in this screen. And here in this screen, you guys have to copy everything. So anything can be asked for 1 marker or 2 marker. You need to know.